Hello guys, and welcome back to another rocket launch live stream. I'm Football Ian, and today we're going to be watching Firefly's first ever rocket launch. So, we're going to put up the stream now. Just so you know guys, this is insane, but weather is 100% go for launch today. This is insane. It's from Vandenberg Air Force Base, California. The launch is currently scheduled for 9 p.m. And yeah. So we're going to switch to the stream now. Okay, so here we go. We're going to listen in now for the next step coming up.
Let me end this down. That's what PEUFED is,
This is being hosted by
on our timeline. Pointy end is up, let me end this down. We're listening in here. Andrew, I don't know if it's in program yet, unless they're just very quiet.
LD, this is CRS.
That's your ass.
I just wanted to confirm that the pointy end is up and the flamey end is down.
Let's go.
Giddy up.
The stream is a little laggy, probably, but it looks like it's getting better.
I love that. I love that. I love... What? I love that we literally just got the pointy end is up and the flaming end is down confirmation from launch director Adam Oakes. That makes my day. That's like, how did that happen? How did that happen?
Okay guys, so I'm gonna go for a little bit, and you guys can watch the rocket and commentary, and yeah, I'll see you guys later when there's an update or about to launch. So yeah.
In 15 minutes, they actually began loading RP1. Now, RP1, when they initially loaded into the rocket, it's just obviously kind of at room temp and at low pressures, and then at which is interesting because take note that T-minus 4 hours and 30 minutes is when they did pad clear. So you can actually have the rocket with propellant inside the tanks, with fuel, especially RP1, because it's not cryogenic. It doesn't need to be highly pressurized. They can just fill it to safe levels to have humans still around. And actually, like the Atlas V does that as well. Pretty cool with RP1 that it can operate at room temperature. So yeah, that's always fun. But then they do pad clearing before the LOX load in. So LOX load was at T-minus 3 hours and 40 minutes. So that's obviously why you start to see these cryogenic, the boil off here. You see all this, what looks like steam and stuff coming off of the rocket. That is actually liquid oxygen boiling off and becoming a gas because it's obviously very cold. Liquid oxygen is down around minus 200 degrees Celsius. And as it warms up from the ambient air temperature, it expands 1,000 times its size and becomes a gas. And obviously you don't want your things inside of a closed system, inside of a closed tank, expand 1,000 times without venting it. It'd be very bad. So that'd be very bad. So that is why you're seeing so much of that condensation boiling off of the rocket as we speak. And then we go into, so that's LOX load. So at T-minus 20 minutes, the countdown net is actually going to be going over the go, no-go poll. Now, unfortunately, we aren't the go, no-go poll. Now, unfortunately, we aren't going to be able to share that audio with you, but we will be able to pick up audio soon after that. So we will actually have mission control audio. We will actually have mission control audio shortly after that. And liftoff, obviously, at T0. So, yeah, that's pretty much that. But I did want to show you one more thing from our
Let's I'm gonna. Okay, guys, let's share. I'm gonna share this first. Okay, guys, so I'm gonna show you this before launch. I'm gonna show you a couple days ago. I mean, like a week ago or two. There was a Firefly conducted their static fire. Let's show you that though. Show you that right now.
O2's 3%.
15.
Water pressure clears the abort.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Burn, baby, burn.
O2's 9%. Diverter looks okay. Plan looks good. 12% O2. Give a plus count, please.
14.
Plus 15.
16% on O2.
Made it all the way.
So pretty cool. And
Ever attempted to fly on an orbital vehicle. The BE-3 engine on Blue Origin's New Shepard uses a tap-off cycle, but that is not an orbital rocket. But that is actually, I think that might be the first tap-off cycle engine to ever make it above the Kármán line. This is the first time a company's attempting to use the tap-off cycle to get a rocket into orbit. The tap-off cycle is a really unique solution. It's relatively simple because you actually can remove your gas generator or your pre-burner from the engine, and you literally basically punch a hole in the side of your main combustion chamber, and you pipe that and have that actually be directed right at the turbine, which is what powers up your pumps. So the hard thing about that is normally one of the most difficult parts is, well, two things. How do you start that, right? How do you start your engine if it requires the main engine running in order to spin the pumps, and the pumps are what spin the engine, run the engine. So if the pumps aren't running, how do you get the engine running in the first place?
Sorry guys, you guys could barely hear me that time because my audio, because the sound was so high for the desktop audio. Sorry about that. So I'm gonna go now. You guys can still watch. I'll come back later.
Get the pump spinning up to operational pressures. Once the engine is up to stable combustion, then that will take over and continue to run the pumps at that point. But the hard part about it too is that the engines typically run closer to stoichiometric ratios, which is a lot hotter than what you typically run a turbine with a pre-burner or a gas generator. Normally those temperatures are quite a bit lower. You run them very fuel rich usually, or sometimes, if you're like the Soviet engines, they would always, almost always run oxygen rich, but you run it far away from anywhere near stoichiometric, and that allows them to be cooler and keeps it so your turbo pump machinery will not melt. So that's another challenge, is how do you solve that? And to be honest, I have no idea how they solved it. I have no idea how they make it so you can use the main combustion exhaust gas to spin the pumps. It just seems absolutely crazy to me. They solved it. It's a really cool solution, and they're using it on both their first stage and their second stage. So they also will use, they have a Lightning engine on the upper stage, and the Lightning engine produces about a third the amount of thrust, if I remember, 75 kilonewtons versus, total of 300. Yeah, so I think it's like 3 or 4 times 184. So yeah, about 2.5 times less powerful, and there's a single one of those as opposed to the 4 Reavers on the first stage. But yeah, it's really cool. But in order to get that one started, now you might go, if they were using ground-based nitrogen, how did they get that started? The vehicle has some high-pressure helium bottles to spin up the second stage pumps, and helium is a better choice when it's on a rocket that needs to restart in air, because it's a lot lighter than trying to compress nitrogen. Nitrogen, for the same amount of energy, basically, it's a lot more dense, so it'd be a lot heavier. So that's our pre-launch preview, and we need to thank Flo from our website crew for writing that pre-launch preview. Again, if you guys have questions, go check that out. I promise you'll hopefully learn a lot more than what I just blabbed on about, which is crazy because we're already at T-minus 30 minutes. I've been blabbing way too much. I haven't got to any of your awesome. I really appreciate all the people that are asking questions. We will get to those, I promise. And don't worry, we've got plenty of time for Coast. And I'm sure, not sure actually, at this point, they're kind of scaring me. They're actually going to go right at the top of their window, which is nuts, which means that, that's a great thing. So obviously, like we mentioned, at T-minus 20 minutes, we do expect Mission Control to give the final go, no-go poll and get into the terminal countdown. That's kind of what we're waiting on next, which is coming up in 13 minutes. But meanwhile, I wanted to do a little camera walkthrough with you guys, because we actually have some really awesome cameras here for you guys, and I'm really, really excited about them. So yeah, take a look at this. This is one of our main shots. Again, we do apologize that some of the frame rates are relatively low, but we might have to work some issues on the back end. But yeah, just enjoy these for now, and we'll keep going here. So this is another shot really close to the back of the strong back. And the flame trench, I believe, goes off from here to either the right or the middle. But yeah, super cool shot. The strong back is what lifts the rocket up and supports it as it awaits launch. Super cool. Next up, we've got another shot. This would be a cool shot to see the rocket go through once it kind of clears the strong back and clears the tower, basically, is what that would be. Then we've got another shot. This isn't the one that's tracking. Is it, Andrew? Oh, this one is. That's a close tracking camera. That's a very close tracking camera. That camera will actually move with the rocket and track it as it begins to ascend off the pad. So that will be one that'll be really fun to check in on soon after launch. All right, next shot, Andrew. This is also another tracking asset. This one's actually infrared, which is very necessary at Vandenberg because normally these rockets end up flying straight into clouds or through fog and you can't see anything. And tracking assets are actually valuable for the launch provider and for the range to make sure there aren't the vehicle's not having an anomaly. And if the vehicle does have an anomaly, it's good data to be able to look back on and see if there's, all the data, the better. And here is another infrared camera as well. So again, basically right back into having the ability to fly through clouds and all that stuff. This one's actually really cool. It's from like very far away on a separate mountain, and it's a little bit shaky, but it's also because it's very, very zoomed in on a long telephoto lens to be able to get that shot. That is also a really cool camera there too. So from the range assets. Now next up we have a camera that I cannot wait. I cannot believe we actually talked them into this. And for those of you that watched, I actually launched or streamed when China sent a rover to Mars. We stumbled upon Trench Cam, and ever since then, I have dreamed of this day when we can officially provide for you guys Trench Cam. So how awesome is that? This is full blown Trench Cam City. Like this is an actual camera right there. Trench Cam, I can't believe it. We got access to Trench Cam. But believe it or not, Firefly, again, I'm not trying to butter their biscuits too much here, guys, but the level of transparency this company has had has just been amazing. They basically just keep saying, sure, sounds good to us. You just do your thing. We were asking if there's a camera that could show engine gimbaling. And we can't show this very long. We're going to show you a real quick little preview, but then we have to turn it off. We have engine cam. We have flamey end cam. That's all we're going to show you for now, but we will be able to show you that at ignition, which, come on. If that's not the coolest thing, what? Yeah, so that's awesome. Trench cam, and this is blowing me away. We actually had an official pointy end up, flamey end down check. We have Trench Cam, and they even took it another level up and took it into engine cam, into flamey cam. So flamey end cam, yeah, unbelievable. So yeah, so that gets us into waiting here. We basically have 9 minutes where I'm going to answer a couple of your guys' questions until we wait to hear about the terminal count. So I wanted to first just thank off all of you that are tuning in and that have decided to become members or super chats. Of course, that helps me pursue things like this and try to provide streams for you guys as well. So thank you so much to members, members, and of course Patreon supporters. Get ready because I'm almost done with the massive dialogue cut of the infamous family tree of the Soviet rocket engines. It's my most ambitious video ever to date. I've been working on it for way too long, and I'm really, really excited. Oh, look at that. We got some venting. That's cool. And I should need to mention too, by the way. Okay, so we'll get back into the Soviet rocket engine fiasco of me spending way too much time on it. But I do want to point out, don't forget this rocket is black. It's entirely carbon fiber. But you will notice that it looks half black, half white right now. And of course, that is because that's where the liquid oxygen tanks are. So the liquid oxygen tanks are what hold on to the liquid oxygen, obviously, and they're still black carbon composite, just like the rest of the rocket. But the craziest thing is that obviously that's really cold. Like I mentioned, it's almost minus 200 degrees Celsius. So that means that ice will end up building because there's obviously a lot of water vapor in the air. Ice will end up building onto it, and you actually have a layer of ice on the rocket, which is why it's white in those spots. So it is a black rocket. But when it's fueled up and ready for launch, that thing ends up being half black, half white, which is just wild to see. It's just weird to see the actual physical formation of ice on a rocket that's going to have a flame that would melt anything, basically, coming out of the other end of it. I just love that. I think that's super cool. So, yeah. So in Discord, someone said it's entered zebra mode. Hunter Cuts says the rocket has entered zebra mode. That's how you know this thing's ready. It is in zebra mode. So very, very, very cool. Yeah, so again, thanks to all of you guys. Get ready for those YouTube members and Patreon supporters. Get ready. We will be putting up a very rough version of the dialogue cut of that Soviet rocket engine video. It's coming in actually, I think I read it a little faster than I normally do because it's so long, and I think it might only be about an hour and a half in length, which is crazy. Maybe an hour 40. But for those of you that like my long form documents, like basically documentary style stuff, this will be the ultimate one. I promise you that it will be the ultimate one. So let's see. I really like this sentiment here from our friend Musical Wolves. Very, very excited to see a launch instead of political space issues. Any launch is exciting. Team Space is awesome. Congratulations on hosting the official stream. Well, thank you so much to Musical Wolves. Yeah, again, we're just beyond thrilled to be able to do this along with you guys. Of course, my goal here at this channel is to bring space down to earth for everyday people and just help you get excited about space flight. And I personally believe the easiest way to get excited about aerospace is to actually be learning about aerospace, is to learn some of those little odds and ends and start, learning about how this stuff works. Because I think when you're educated about a subject, that's when you really get excited about it. So obviously the whole goal of Everyday Astronaut is just simply to break down stuff that's complicated and try to make it explainable to you guys, normally through long form content that is, has a lot of good visuals because I'm a very visual learner. But yeah, this is the ultimate dream for me, having a rocket provider actually wanting me to stream their launch. It's just crazy. So, all right. So let's see. This is interesting. This is from Wily Coyote again about the buffer issues. If you guys have problems still with the feed, try refreshing or going back in the feed a little bit. But if we need to, we might have to refresh one more time. But I think it's probably stabilized a little bit. Again, the dropped frames of the rocket will probably maintain. That's been a persistent issue for us with this transport. But yeah, we appreciate your patience and hanging out with us. We think it's pretty cool that we have all these camera options and that we get this much insight to everything. So not bad for a first stream of an official rocket company. All right, so this is a good question again from Musical Wolves. Do the fairings have trackers even though they aren't being recovered? Are fairings considered space debris? Well, don't forget, fairings normally deploy soon after stage separation of a rocket. So when the first stage and second stage separates, the first stage typically ends up splashing down only 200, 300, 400, 500 kilometers downrange, depending on the trajectory and the mission. That's where the first stage splashes down. Now the fairing will remain attached to the upper stage, which will accelerate it a little bit more. But normally the fairings deploy soon after second stage engine ignition. So second stage will, kind of run for a couple seconds or, 20, 30 seconds, and then they'll do stage fairing separation. So those fairings are not yet orbital. Those fairings are still suborbital at that point because the vehicle, it takes another 6 minutes or so of acceleration to get a vehicle up to orbital velocity. So because they ditched their fairings before they orbit. Oh, interesting. Apparently we're getting double face. Yes, it was. That was 100% my fault. We were seeing streams come up on my face. I am sorry. So anyway, so don't forget the vehicle doesn't actually get into orbit until much later on, several minutes later. So the fairings are still suborbital when they let go, which means they splash down 500, 600, 700 kilometers downrange. So they don't need to be tracked in space because they won't maintain orbit or anything. They will come back down 10 to 15 minutes after launch and then become little boats for a little bit and eventually be succumbed to the ocean where they become a coral reef. So yeah. Let's try to get to a couple more questions. Yes, this is a good question here from Norbert Daniels. Again, if you guys are asking good questions, we'll try to pull them up on stream when we have time. Doesn't a retrograde orbit mean more delta V required? So doesn't it mean more energy to get into a retrograde orbit? And the answer is 100% yes. So normally, obviously, if you're launching prograde, if you're launching with the rotation of the Earth, you get that extra bit of spin. So the Earth is helping, quite literally flinging you and giving you almost, I believe it's almost 1,000 meters per second, almost a kilometer of delta V. Is that right? Can someone let me know? I don't remember. Is it only like 400? I don't quite remember offhand. I'm sure Discord will know. But yeah, so the cool thing there is that that the Earth normally helps you get into orbit. Now, when you're going into a polar orbit, you actually kind of have to negate the rotation of the Earth, and when you're going into a retrograde orbit, you have to go opposite of the rotation. Making it into a cool interactive thing like this for you guys. So yeah, you guys, I have an awesome team. We'll put it that way. Let's see. This is a really good thing that I want to bring up from Orange man. Good evening, Tim, Ryan, and Mary Liz from Cosmic Perspective had a fantastic launch of their Road to Mars series. Have I seen it? I had to stop what I was doing today, set aside the 30 minutes to watch the first episode of Road to Mars from Cosmic Perspective because it was incredible. Those two work on something so hard and put so much effort into their videos. It's just unheard of. Their way of storytelling is amazing. If you guys aren't familiar, obviously, with Cosmic Perspective, they are who help us a lot during, obviously, during Starship launches down in South Texas. But, you know, it's really fun to see how they do storytelling, how they share their images. And it's just been an awesome partnership. So I'm so proud of the work they do. And that made me teary-eyed. Now, give us a second here. I believe we may or may not be trying to refresh the camera feeds here. So hopefully we can try to eke out a little less lag here for you guys. But we will get them back in just a second while we continue to answer questions. So this is a great question from Razenbot. Many light launchers now. Do you think they will all find a place on the launch market? That's actually kind of the ultimate question to me as an aerospace fan is there are a lot. I mean, I did a video about the small sat launchers that are kind of coming online right now, comparing some of the ones that are getting really, really close to flying. And Firefly obviously was in that. And I kind of said at the end of the video, I personally believe, you know, if you can get a rocket on the pad and get launching and attempting to launch this year, you're probably on track for you know, survivability. But if your first rocket for small sat launch is 3, 5, 10 years away, you're probably going to be just too late unless you do something totally groundbreaking, something completely different. But I think right now there is still some room for a little bit more. You know, a couple more in the game. There's some really exciting rocket companies that are coming online here, and yeah, I think like I said, I think if you have a rocket on the pad this year, you're looking pretty good. But the race is definitely on. So Firefly, if they happen to get to orbit, I need to mention, by the way, guys, I don't even know if I've said this. At least no private company's liquid fueled rocket, or no private company's first rocket has ever made it to orbit on its first attempt. The closest would probably be the Electron, Rocket Lab's Electron. The vehicle was actually good. They lost a ground track station that allowed them to continue tracking the rockets. They actually had to terminate their first launch, but they were close. They probably would have done it, sans that. If Firefly happens to make it to orbit today, which again, remember, this is a test flight. This is the first launch of a brand new vehicle from a brand new company. If they get off the pad and start making some data, that's going to be progress for them, right? So we just want to cheer on any progress. But yeah, they're aiming for orbit. They're going for orbit fully. It's really impressive. You have to think about all the extra details, you know, the guidance and telemetry. Okay. Poll is done. They are go for launch. That's awesome news. So we are now within terminal count. They're actually going for the beginning of their launch window for a new rocket company to be attempting their very first launch at the beginning of the launch window. This is super impressive. I'm starting to get chills here. This is awesome news. So yeah, that is super. I can't believe that. I'm sorry. I've been tracking this program for so long now that it's just hard to believe that they're actually going for it already at the beginning of the launch window on their first attempt. So let's see. Yeah, this is nuts. The enthusiasm on my end, guys. I'm sorry. I will probably move the mic when it gets closer to launch. I actually try to tamp my enthusiasm on air. Believe it or not, I know that sounds impossible, but I get really when I've been working on this stuff, and following it for so long. You get really wrapped up in it. Just like sports fans, you guys know what that's like. I guess I am a ultimate spaceflight nerd, and I get really excited about this stuff as well. So yeah, I would never, like I said, I actually try to tamp it down a little bit for you guys, but I'm starting to get chills just thinking that we're only 16, 17 minutes away from T0. This is crazy. So yeah, we're going to keep going. So actually that made me think about, I've been following this company for a while, but the first video that I ever saw of them, they released about a year ago, I think, maybe a little beyond a year ago. And it was them reaching out, to ask people if they wanted to have their payloads flown. So Andrew, if we have that video, I actually wanted to roll that. And also I wanted to roll, we also have some really cool footage from them from some of their testing campaign, because this company has really, really, really cool stuff. So we're gonna pull that up here for you guys in just a second. Like I said, this was the first video I saw.
Making space for everyone has been an essential part of Firefly's vision and dream since the day we began. We've been working tirelessly for the past few years to develop Alpha, a game-changing small satellite launch vehicle. And finally, our first launch is within sight. I'm proud to announce today that we're extending the capacity of our inaugural launch to you. That means we've reserved a spot on Alpha for you to send up whatever dream payload you can think of. We're calling the flight opportunity Dedicated Research and Education Accelerator Mission, or DREAM Payload. We encourage educational institutions, startup space entrepreneurs, or any other institution that has big space dreams to visit firefly.com and tell us about your dream space payload. On the website, you'll find all the details and specifications you need. We look forward to hearing from you as Firefly marches toward first flight, perhaps with your dream payload aboard.
So yeah, like I said, that happens to be the first video that I ever really caught of them, because they've actually been around for a while, but they had a restructure of their business. They used to be Firefly Space Systems, now they're Firefly Aerospace. So they actually had a clean slate rocket. So they basically started over only about 4 years ago and got out to the pad this quickly, which is extremely impressive. Again, everything I'm talking about, by the way, is like unscripted. It's just me talking to you guys about this stuff, which again, thank you, Firefly, for even trusting me with any of this stuff. But yeah, so it's pretty impressive to me, again, as an outside perspective, to go from a clean slate design and a new company restructure to only 4 years later having a rocket at the pad. Honestly, super cool. Now they're based out of Austin, Texas, their headquarters. Oh, also good news is we can actually listen in. We're going to pull up mission control audio. So if anything does come up over the comms, we will hear it live with you guys. So we'll all be informed together. Again, another transparency thing from Firefly. They're giving us a listen in to their mission control. Super, super cool. There is actually a few more videos. So, as Tom walked away there, you did see that there's...
T-minus 14 minutes. RC, please contact the range and coordinate to begin recording RF tapes at T-minus 10 minutes.
Confirm.
This field. Sweet. They're going for it. They're going for it. This is crazy. So, okay. There was a few more videos. Like I said, they have an awesome set of videos for their testing campaign. I actually wanted to run just a few of those testing videos for you guys because it's really cool. So this that you'll see is a startup of 2 of their Reaver engines.
Ground side preparation for PFAB and simple verification has completed. T-minus 13 to T-minus 10, we will now report action. In the event of an abort, we will perform the following steps. We'll confirm there are no fires around the engine, which utilizing siren by LP. Confirm the fire should be confirm vehicle health. Pre-valves are closed. Vehicle health. Pre-valves are closed. Bubbles active. That's when vehicle verify other vehicle things. Confirm ground side health. Two
trying to hear you.
We'll power off stage 1, stage 2 FTS.
I just wanted to kind of point out a few things here about these videos. So this is at their site, which is about 45 or an hour northwest of Austin, Texas, kind of in the middle of Texas. But this is one of my favorites because it is the all-up test of their first stage booster. That's the one that we see right here, right now. This is performed, I believe, last year. Now I wanted to notice the engine gimbaling there. I wanted to call out something interesting about the way that their engines steer. They're actually only single axis gimbals, but because you have 4 engines, 2 of them can go on one axis and 2 of them can go on the other axis. So between the 4 engines, you actually have all 4 axes of control. Now, this is also a little clip from one of their, this is a short duration static fire they had at Vandenberg Air Force Base on the pad just about 2 weeks ago, I believe. They did some static fire testing. I just thought this was really cool. Slow motion video. You gotta love it. You will notice there's a bright green flash at the beginning of the burn, and that is using T-Teb. So they use the same igniter fuel that the Falcon 9 uses to light up its engine. And that's triethyl aluminum, triethyl borine, which is a pyrophoric fluid. So as soon as that comes in contact with liquid oxygen, it begins to combust. So it's a nice, simple ignition fluid. Super cool. So you actually could see that at the beginning of that attempt. So, yeah, we're going to keep listening in here to comms. We're hearing a little bit of chatter. It's fun to hear some of that stuff about, like, you know, what if this or that happens? They're going over all their procedures. But we are within T-minus 10 minutes. I kind of can't believe it. Yeah, this is pretty wild. But yeah, real quick again, back to the engine gimbal. So I want to be able to use my hands to talk because that's how I normally talk. So basically, you have a set of engines that can gimbal this way, a set of engines that can gimbal this way. And between them, you can do roll by having them all kind of gimbal opposite each other, or even a pair just gimbal opposite of each other. You can go, pitch or yaw just by using a set, and basically together to be able to do pitch or yaw with those 4 engines on just a single gimbal axis. That's pretty unique, but it's one of those kind of simple things. Like, why put 2-axis gimbals on every engine if you can get away with only using one? The best part is no part. So super cool. Man, yeah, again, sorry, I'm still just like, I'm trying to catch up to the idea that this thing's actually going to launch in T-minus 9 minutes and 40 seconds. All right, so let's see. Yeah, so this was again from Musical Wolves asking about Trench Cam. Again, I hope that you guys saw our camera walkthrough. Andrew's kind of giving you guys a little taste of things, but we do have Trench Cam in this broadcast, which is unbelievable. Super, super, super cool. So we're really, really excited to be able to show that. Now that'll get obviously completely smoked out almost immediately.
See, it's countdown 1. Range confirms. Recorders are on.
Copy.
So basically, they're tracking assets. The cameras are on and recording, which is a good thing because especially when the vehicle is fueled up at this point, it is awesome to be able to see it at that capacity. So, all right, so. This is a nice little fun thing. Best first launch stream from any company. Hope it doesn't go sideways. There's been some, the most recent Astra launch was unbelievable. I couldn't believe with the NSF crew doing that stream, the fact that the rocket made it off away from the pad and began to actually ascend was really cool. I was cheering like crazy. I was doing the disbelief sign, like, what? As it was power setting off, it was incredible amount of guidance and control for that rocket.
Can we get stage 1 fuel tank pre-press?
But again, really excited that this rocket is ready to go. That Firefly is letting us stream their first attempt ever. Like, that's so cool.
It's up on the left screen.
Good.
Copy.
Go ahead and change that. Flight software takes care of it for what we want in the last 30 seconds. So you're good to support.
Cool. All right, let's keep going here. So yeah, again, this is from Alexander asking, how does retrograde orbit affect payload capabilities? So it can be, I think it's about, so normally if you're going from like a normal prograde orbit to say a polar orbit, you lose about 30% of your performance. I'm actually not sure. I think you still lose only about 30, maybe a little more when you go retrograde. I think you would actually lose a little bit more. But you, like I said, though, you do actually have to still negate your velocity, your rotational velocity when you go into polar anyway. But yeah. All right. This is from Kyle Jones. This indeed is their first orbital launch ever of their Alpha vehicle. Again, super impressive that they are streaming this entirely. I mean, I just feel like that's pretty transparent. I think as far as I remember, and I got corrected on this. The only other company that ever did that was SpaceX with their Falcon 1 way back in the day. Way back in the day, they did that. We had some people kind of asking about size and everything. I should kind of remind you guys of the size here. This thing is about 30 meters tall, so 95 feet tall. So it's like I said, it's a pretty good size small sat launcher. Andrew, I actually do have that chart pulled up here if we want to give kind of people a size comparison compared to some other small lift launch vehicles. But yeah, it's basically 30 meters tall, 95 feet tall. So it is, yeah, it's a good sized rocket. And it is, sorry. And then as far as width though, too, it's 1.8 meters wide. So it's on par. It's almost the exact same width actually as Virgin Orbit. But yeah, if you compare it here to the Falcon 9, you can see still how big a medium class rocket is. Quite a bit larger than these vehicles, but Firefly's Alpha is actually a very big small lift launch vehicle. As far as small lift launch vehicles go, it is quite large. So yeah, again, if you guys have questions about how Firefly's Aerospace, their Alpha rocket compares to other launch vehicles, we do have that up at our website too. We had a video comparing all of these rockets together that you see on screen right now here on YouTube. So after this launch, if you have questions about how this vehicle compares to others, go ahead and check out that video. It should give you a good rundown. Let's listen. Let's listen in. It should give you a good rundown on kind of everything, and especially this vehicle as well, to kind of tell you about the tap off cycle a little bit and stuff like that. But yeah, again, let's see here. So
please begin dispositioning LCC gate checks for T-minus 2 minute checks. Attention all, any no-go at this time will be an automatic abort. Again, at the T-minus 2 minute call, any no-go will be an automatic abort.
In work.
So that was in work. So
T-minus 5 minutes, the strongback is secured in its launch position.
Wow. All right. So that is the strongback retract. Andrew, go ahead and check that off on the list. That is awesome. That's a good sign that things are moving forward on time. I can't believe this. It's running so smoothly for a first launch. Wow. I don't even know how they're doing this. So the next thing we're going to be seeing here in just a couple minutes, we might hear the call out for it actually any second here, will be that the flight termination system is armed. And actually, I think that call out is going to be around T-minus 4 minutes. We should hear that on the net. And that's going to be the system that if the vehicle were to happen to have an anomaly and start to stray off course, they have the ability to terminate the rocket.
Here we go, guys, under 5 minutes to launch. And I'm going to go watch it with my family. So I won't be here, but you guys can watch it, watch the audio, and I'll come back after and we'll talk about it. So, yeah, hopefully it goes good.
Check channel 4.
FTS confirms that FTRs are active and range is transmitting check channel 4.
Note, the ARM Enable 2 command must be received by the ESAD within 30 seconds of receiving the ARM Enable 1 command. FTS, send ARM Enable 1 command to all ESADs.
ARM Enable 1 command being sent in 3, 2, 1, mark.
FTS, send ARM Enable 2 command to all ESADs.
ARM Enable 2 command being sent in 3, 2, 1, mark.
FTS, confirm when all ESADs are enabled.
All ESADs are armed.
FTS is armed. All right, well, we can check that one off.
3 minutes, fuel bleed will begin.
Okay, so the next thing on our list, they will actually do an engine gimbal check here at about T-minus 2 minutes, if I remember right. We won't be able to show you that, but we will hear confirmation, hopefully, over the net that is indeed go. And they'll also do a go for launch here. They'll do the go for launch at T-minus 2 minutes. So We'll listen into that and hear hopefully from Launch Director Adam Oakes that everything is still good to go. That is kind of the final thing. Like, assuming it's all good to go from here, they're going to light this candle in just 2 minutes.
LCC on CD1. T minus 2 minutes. Let's go.
Copy.
I think that was go for launch
Close events.
already. That was... Okay.
T minus
going
2
for
minutes. CE has performed the final check against LCC 10. This is the final commit for launch. Chief Engineer.
Send it.
Launch Director.
Go.
LDA.
LDA, your go for launch.
Thank you. Step 3.9 to 29. VC verify alpha transitions to autonomous mode at T minus 30 seconds. To
We'll
stop
go.
the count, operators declare abort, abort, abort on CD1, and VC will abort the auto. Thank you.
$60 seconds.
So they will begin engine ignition at T minus just about 2 seconds. So
Complete's doing its thing.
we'll see the green flash around then. And our clock might be a tiny bit off. We apologize for that if it is within a couple seconds, but it's good enough for now.
30 seconds.
VC verify alpha transitions to autonomous mode.
Autonomous.
RC give the final 10-second countdown on the net with positive calls.
Abort. Which we've aborted.
I think they're going.
Confirm there are no fires on the video.
See no fires on the video.
GC close world purges.
Oh, was that an abort? That was an
VC
abort.
confirm the following 3 valves are closed.
World
Okay,
bridge
they
closed.
did
3 valves are closed.
Confirm helium bubble
Abort.
is active.
Filling bubbles active.
Confirm S1 fuel tank is maintaining between 30 and 36 psia.
Maintaining pressure.
And all other tanks are vented.
Vented.
GC confirm the following T-type tank is vented.
Barely in the terminal count though.
Vented.
Confirm TBC tank is vented.
Venting.
Confirm spin system is vented and cavity purges are active. VC verify the following. C Rio is in the release safe state.
Standby 1.
Spin system is vented. Cavity purges are active.
Thank you.
Now, just a little heads up, guys.
Cheerios in the safe state.
Friendly reminder here that
Confirm
this
vehicle
vehicle, they do have a
SSW
4-hour
manual
launch
state,
window, so
and
it's
the auto sequence.
not over yet. They had
Manual
something
state
similar
and
to
auto
this
sequence is complete.
when they did their static fire.
On
They actually were
CD1,
able
the
to
release
get 2
system
static
is now
fires in
safe.
during their
FTS
window.
confirmed with
So,
range are okay to disarm and power down the ESAD.
And work.
CRS
so we're gonna listen here.
57 pad area camera scan.
Yes, sir.
Okay, so we're going to let them work the issue here, and we will await to hear from them on anything official if there's a chance to reset today. Which there might be a chance to reset. Andrew, when you get a second, go ahead and put abort on the T plus clock. But yeah, that's obviously again, this is completely, frankly, expected on my end. I would assume that the very first launch, there's going to be a couple things that they need to just kind of tweak. And they want to be extra cautious again. You know, you don't want to just send the vehicle if there's anything that triggers any kind of abort, obviously. So they must have seen something that didn't quite look right. They're going to be going over all of their, go over everything and see if there is a chance to recycle today and go for a launch opportunity again. Again, remember, there is a 4-hour launch window today. But the fact that they got that far into the terminal count on their first time, of their first ever orbital rocket, again, was way ahead of my expectations. I can't believe we're even launching on their first launch day opportunity. There is a backup tomorrow if there is something that if they actually need to defuel the rocket and go out and tweak on it. That will be likely a scrub for the day. But if the vehicle's fine and the systems are good, they'll give her a checkout, and they'll hopefully be able to repress and go for another attempt here this evening. So fingers crossed, we'll wait to hear from them as soon as we can. But in the meantime, this is why it's fun to be able to have you guys to hang out with, because I am waiting just like you. So yeah, so everyone just send a quick little, send some love off to Firefly and some patience virtues, because this is rocket science. So this happens even to the most flown rockets in existence will still have things happen like this as well. So so yeah, we'll just give them a little bit of patience, let them work the issue, of course, do their job, and hope that they can, you know, maybe reset for today. If not, we will be here tomorrow. So hang on. Yeah, I'm just getting confirmation here. Okay, we just got official confirmation that they are recycling and going for another attempt. Now we'll update our clock here as soon as we know. Andrew, this is actually probably a good time if you want to pull up a video here. I'm going to take a little break, do some tweeting, updating people that were waiting a new T0 time. We'll get back in once we get, as soon as we can. I'll probably just take a quick little break. And then what I'll be able to do at that point too is hopefully get a little bit more information for you guys. And so we can update you guys, but then we'll answer a bunch of your questions. So you guys have been awesome. I like that you, that again, Firefly's trusting me to just answer questions on the fly. Super cool. But I love that they're just basically treating it as my stream, and they're just allowing us to see it. So again, thank you, Firefly. You guys are awesome. So that being said, I'm just going to take a real quick little break while we wait to hear about the recycle and while we await a new T0 time. So don't you go anywhere. We'll be right back.
Firefly is growing very rapidly. We're looking for new team members that are into the mission of new space. Going to space is probably about the hardest thing you can do. If you can achieve it, you've done what is seemingly impossible. We're not just buying other people's stuff and putting it together. We have to engineer all the pieces, parts, put them into assemblies, and test them for the first time. We have to solve problems that none of us have solved before. Firefly's goal is to build a rocket that can get small satellites to space. The kind of people I'm looking for here at Firefly are people that have fire in their belly, that have a passion for space, but not just that, they're people that have distinguished themselves in their career in academics. They know their subject. They're serious people who like to get things done. I'm not really hung up on getting people that are experts in rockets right up from the outset. I want people that are very technically astute and have a passion for space and can learn the things they need to know to build rockets.
The challenges and problems make you dig deep and think like you've never thought before.
I made the modifications for the thrust chamber to interface with the new...
You get to imagine things and try and make them a reality.
This place is fast-paced. You always have your next goal. We're always hustling.
At Firefly, you'll get opportunities to have a meaningful leadership role in a company right from the outset that you wouldn't get in a larger company. Space has always been intriguing, but what's unique about this time now is that there's big business to be had in space. Its estimates are on the order of $3.2 trillion in revenue by 2045, dwarfing any other business.
Final configuration. Operator, please check NPTO1.
Everyone at Firefly partially owns the company. So if you come to Firefly, you'll get equity. If we become wildly successful, everybody's going to get carried along, and you're going to do very well financially.
We're all owners of the company, so we're very motivated to get to launch. Even those who aren't going to be very rich are going to be very comfortable.
Firefly is in a stronger position than it's ever been. We have an investor that's dedicated to pay the entire bill to get us to space. We do need some more people to help us get to the next level, but everything is in great shape right now at Firefly. People are the most important thing at Firefly. You know, I'm the CEO, but I'm out in the field working with the team on building the rocket engines. We're just a bunch of guys and gals trying to do something amazing. You won't find hierarchy here or a lot of roadblocks or bureaucracy.
The culture's very sort of family-like.
Test execution. RE. Verify blue lines are met. Operators stand by manual abort. Start camera recording and start auto sequence and provide a countdown.
Starting auto sequence. 5, 4, 3, 2, 1, 0.
Firefly is great because you really feel like that you're putting your personal touch on this vehicle and on this system.
Just an amazing feeling.
Working here, you get an opportunity to work on something that's going to be very impactful, literally extending humanity's reach into the universe. And that's something, in addition to being economically secure, you can look back in your old age and be proud of and talk to your grandkids about.
Right, and welcome back. Unfortunately, we don't have any new updates for you guys for a new T0 time, but that's okay because we can use this time to answer some of your guys' questions. Again, I will try to do everything in my power to get to as many of these questions as possible, but with the amount of people watching right now, we probably won't be able to keep up with everything. We definitely can't keep up with everything, but if we have good questions, they don't have to be super chats, guys. We put up lots of just regular chats for you guys. If it's a good question, we'll try to get to it. But yeah, I really enjoy the fact that that we are able to just kind of hang out with you guys together. So it feels like we're all watching this together. So there was a chance for a little while. I was working on trying to do this in person. Unfortunately, I'm still recovering from COVID. I'm feeling 99% better, but energy swings are pretty massive still, even 3 or 4 weeks out later. So so that being said, we are doing this all remotely. But there are probably some people out there in California that are buddied up, parked around Vandenberg Space Force Base. Sorry, not Air Force Base. So hopefully there's people that are there to watch it in person and watch this launch attempt today. So we're still hoping. Again, there is a 4-hour launch window here today. So there is a chance that this vehicle will recycle and they will be able to go for another attempt here within that 4-hour period. So we are officially only 10 minutes into the launch window, so they have plenty of time left. So yeah, so just to confirm, I did see some people asking, yes, Firefly, the company, is in Texas and they do their testing. Their headquarters is in Austin, but they are launching out of Vandenberg Space Force Base in California. So they're launching on the West Coast. Yeah. So let's see. This is a good question from Crypto. Are there engineering cams so we can see the rocket after T plus like 100 seconds? We actually do have a onboard camera that we will be able to show once this vehicle leaves the pad. That is something we will be able to show for you guys. And the other fun thing about this too is, again, that we have the awesome tracking camera assets from Vandenberg Space Force Base. So we will have some of the best telescopes in the world pointing at this vehicle, and we are able to share those views with you guys. So yeah, so stand by. Again, hopefully if this thing does happen to go off today, we will be able to show you all of the normal views. Plus there, of course, with any rocket launch, you do have moments where you are not over top of a ground tracking station. So therefore there are moments where you don't have video link and data. So so during those periods, those are known loss of signal pockets, basically known blackout periods. So we'll let you guys know about that if that is if that actually is a thing. This is from NASA Spaceflight. Our president of NASA Spaceflight just wanted to pull this up, saying Buran was better than Shuttle because of Energia. And I would agree with that. Energia was incredible. Again, we will be talking about that quite a bit in my video about the entire history of Soviet rocket engines. And yeah, Energia was just an incredible rocket. And yeah, stand by for that. Again, hopefully I'm getting pretty far into the dialogue cut of this massive video, and Patreon members and YouTube members will get be able to see a version of it where it's just me talking. Basically, I have almost no B-roll, but what I'm going to do, because this video is so overwhelmingly complicated with literally like 100 engines on this chart. I will put the chart up on screen for you guys as I'm kind of talking about stuff. So you won't be totally left in the cold, because otherwise that would be a really hard video to watch, is me just sitting there talking to you for an hour and a half, even, you know, as a perk, as a little preview, but still that would be, I don't even think I could do that. So, all right. Let's see. This is a fun one. This is from astronaut candidate Arthur Channel. This is 100 plus sixth grade students at Beckman Middle School with Todd Cohorst standing by waiting to watch Henry the astronaut fly to space. That is so cool. Todd's responsible for education outreach. CDC's mission microgravity. That is super cool. Well, hello to all of the students over there at Beckman Middle School. For those of you tuning in, that's very awesome. We're excited to hopefully see your payload launch to space today. Again, this is rocket science, and there are delays to be. Oh, we have a new T0, my friends, and it's not too far off, actually. That's pretty impressive. Wow. Okay. They are going for a new local T0 time of 6:59. Interesting that they didn't just go with 7, but 6:59. I'm going to go ahead and tweet that here for a second. Give me 1 second. Wait, what would that be? That'd be 1:59 UTC. 6:59 Pacific, PM Pacific. That would be 1:59 UTC. Awesome. All right, so we've got the clock back to T minus 44 minutes and counting. That's not bad. That's a pretty quick recycle. That's good for those of us that are spaceflight fans. Again, for those of you, if you've been around before, watched rockets launch, especially test flight vehicles and first launches, I'm looking at you, Starship. You guys know what it's like sometimes when you're just waiting, going, is this thing going to launch today? And just that kind of those ups and downs. But you know that sweet and what's the saying? The sweet and salty? No, the sweet and sour. There you go. You know, you have to experience the sour in order to enjoy the sweet. So sometimes having a vehicle scrub and kind of play with your emotions a little bit just make it that much more rewarding. That's at least for me. I know that's true for me. Like I have been to, I think the one that was maybe the ultimate for me to see in person was EFT-1. It was the first time that that NASA's Orion capsule flew on top of a Delta IV Heavy rocket out of Kennedy Space Center. And I think it only actually scrubbed one day, but that reset, I mean, it was a 24-hour scrub, but you know, there's like a 4-hour window and we're sitting there going, is this thing going to fly? Is it gonna, you know, and just that whole thing. But by the time it took off the next day, I was like so excited to see it fly. I don't know, something about that. It's just a normal part of space flight. You guys, if you're new, you'll know, you might not be familiar with that, but those of you that know, you know what it's like. So, let's see. I'm not sure what all these mean, but that's cool. Let's see. Okay, this is an interesting question from Tanner. I'm just getting here. I was wondering why you think, or wondering what you think of replacing stage 0 with a magnetic levitation train angled up the side of a mountain to get some initial velocity. So we get asked questions like this quite a bit. You know, why don't they launch from a mountaintop, or why don't, you know, or air launch like Virgin Orbit does? The simple matter of fact is, you know, you have to consider the cost of what it takes to have. Well, first off, for a mountain, it's really considered a big no-no to fly a fully fueled rocket over populated areas. So you'd have to find a mountaintop that is right next to the ocean. You know, any good sized mountain likely isn't anywhere near the ocean, especially on an eastern seaboard, right? So if you wanted to say launch from 3 kilometers or something on top of a mountain, that's a pretty big mountain. That's still not very much vertical velocity either. You know, you're still not, you're not getting any velocity. And there's a lot of velocity involved in reaching orbit. You need to be going almost 28,000 kilometers an hour, 17,500 miles an hour sideways in order to actually get in orbit, because you have to, you know, think of it like if you launch if you threw a football, it's kind of going to go up an arc. But if you want to throw it further, you need to get a lot more velocity and it will arc. And then you just think about the faster you're making something go, the further that arc gets. And eventually that arc gets big enough to literally just go around the world. And assuming you're above the atmosphere, there's nothing to slow you back down, and you'll maintain that orbit for a long time. There is, of course, still, it's not like the atmosphere just turns off. There's still a trace amount of atmosphere in low Earth orbits, so eventually stuff there does deorbit, but that's besides the point. That's the general concept. But as far as things like levitation, like magnetic, trains, or having something throw a rocket, you just look at what would the cost of that system be? What is the danger of that system if something goes wrong? And one of the biggest things is it's really considered a good idea to turn your rocket on before you let it go, right? So if you're throwing your rocket off of a
Endless experiences to leave you endlessly transformed. From dining that delights to rejuvenating spa-scapes, a world of experiences are waiting. Where can we take you? Marriott Bonvoy. Tap to find your experience.
hey, boop, and it just, falls on its face, and that would not be a good thing. The other big thing too is, what's it actually cost? How much fuel and how much bigger do you need to make the rocket to just launch at sea level, where you have infrastructure, you have people, you have roads, you have all of these things that are good when you're having to work on the rocket, work on the launch pad, get trucks out there with fuel, all of these things. Imagine having to get trucks up a mountain every time you have to launch a rocket. Like, it'd just be a logistic nightmare. There's a lot of these considerations. And at the end of the day, the general consensus for everyone is it's just a lot easier, a lot simpler to just launch at sea level, even though you're not getting that extra bit of, vacuum optimization out of your nozzles, and you're not getting any extra velocity per se, but that's, so looks like we may need to have you guys, you guys might need to refresh. Some of this could actually be on YouTube's end. We've had this happen before where YouTube, the stream aggregator on YouTube, actually kind of lets us down, and this could be one of those days. I was actually having problems with YouTube earlier on my phone even, so who knows? Refresh the stream here if you guys are having problems. It might be on YouTube's end for once, believe it or not, but you never know. All right, so let's keep going here with some of your guys' questions. This is a good question here from Eric Stens saying, first off, thank you very much. What sort of payloads is Firefly expecting to fly in terms of weight and size, and how does this compare to other providers? So again, we did a video about this here recently. So they can, so Firefly can launch to a sun-synchronous orbit. It can launch 630 kilograms. Now, if they were to launch just to LEO, like a more of an equatorial orbit, they could actually reach, they could do a full ton to orbit. They could do, which is pretty impressive. But they are limited to 630 kilograms, but that's still a lot. That's bigger than everyone else that has flown to date so far in the small sat launch industry, or has even attempted to fly, including what Astra is currently flying, what Rocket Lab's currently capable of, and what Launcher 1 is currently capable of. So again, going to sun-synchronous orbit, which is basically like a polar orbit, it can do 630 kilograms as opposed to Launcher 1's 300. Rocket Lab at that is 200 kilograms. And Astra currently is, I believe, 50 kilograms. But I feel like they actually, that might be to just LEO. They might be slightly, but I think it's about 50 kilograms. So it's actually a pretty good size. You can launch pretty decent size, small, not just CubeSats, not just, smaller 1U, 2U CubeSats and stuff like that, and small sats. You can actually start getting into the bigger size small sats, which is really cool. So they are tapping into a slightly, the upper end of the small sat launch industry. And they can also stack multiple satellites inside of their fairing and launch multiple small sats. So it's pretty cool that they have that capability, that it is on the bigger end of the small sat industry. And I think, a lot of these companies are trying to find that sweet spot here. They're trying to find what's the cost of this launch rocket? What's it cost us to make it and fly it and do it again every time? What's that actually cost us? How do we make that profitable? And most importantly, where are the customers at? How many customers are there for our capability of rocket? It doesn't make any sense to make a bigger, more powerful rocket if there aren't those demands and payloads. At the end of the day, sometimes just the bottom dollar matters most for some people as opposed to capability. If you're not fulfilling that capability, why build it bigger, right? So that's what all of these companies are kind of working on doing, is finding that sweet spot. Again, one of the things that I like about what Firefly did is the Reaver engine being relatively simple. It's simple and it's elegant and it's very few parts compared to a traditional gas generator or closed cycle rocket engine. But they still had to work some magic, like I was talking about earlier, because it is tap off. They had to make sure the turbine can handle the main combustion exhaust, which is, they probably worked a little bit of magic to make that happen. But at the same time, at the end of the day, that's probably a relatively easy engine to work on and produce and go through the testing campaign. It's relatively small. It's extremely powerful. Its thrust to weight ratio is probably pretty great. The specific impulse of them, the sea level one doesn't quite reach 300 seconds of a specific impulse, but the Lightning gets, I think it's around 330. So again, you lose a little bit of efficiency when you actually do the tap off cycle, but it's, as far as being simple and easy to manufacture, without having to worry about a pre-burner and all that stuff, it should be a really good idea. So yeah, I'm excited about that. So 322 seconds says Flow in a vacuum. Thank you for reminding me. Let's see. Yes, sorry about there appears to be some sync issues with my audio and video. We'll see. We have kind of limited capacity at this point. There we go. We're seeing some big puffs of gaseous oxygen. That is probably good signs of, the recycle going forward. So, like we said, we actually do have confirmation that the T0 is still up to date. And again, they are targeting 6:59 Pacific time, which is 1:59 UTC. For this next launch opportunity. And another reminder, they do have a full 4-hour launch window. So as long as they don't run out of fuel, because every time you do retop off a rocket, you typically have to pressurize it and kind of continue to load it. So but they can sit there generally pretty happy, fully fueled, especially RP1, no big deal. Liquid oxygen, you might have limited, finite amounts of liquid oxygen available, as we are kind of hearing some of that. So, let's see. This is a good question here from Shikamu1 saying, could Alpha send things to the moon or Mars? Or will we need to wait for version beta to fly? Absolutely. A small sat launcher can send things to the moon, 100%.
Yeah, right
Can't
now,
send big things to the moon, but it can send stuff to the moon. Again, the Rocket Lab's Electron is actually already flying something to the moon, supposedly really soon. I think that's going to be...
you coming?
Walk. Okay, come. Where is leash? Where's leash?
You took his leash off, right?
Oh, there you are.
into orbit as a launch provider.
Oh.
So this is a big
sorry
deal.
about that,
This is
guys.
again, no rocket
15 minutes to launch.
launch providers tried streaming their first
I think I
attempts
had my
because
audio
typically,
on, sorry
to be
about
perfectly
that.
honest, they're typically
Dang
pretty
it.
messy.
And the desktop audio wasn't even on. Dang it. Sorry, I'm so bad at live streaming, just so you know. Sorry guys, the quality is getting really bad.
Will kind of go quiet if I hear things on the net.
So yeah,
but
again,
15 minutes. The auto
15 minutes
sequence
to
is now
launch.
synced with the countdown
It
clock.
looks like it's going good.
That's awesome. So, okay, again, just a friendly reminder, though, is that if this does not go as planned, it's still a huge milestone.
14 and a half minutes. The engine chill has begun and FireX is configured.
Cool. They're progressing forward. So, so let's make sure we have a positive attitude as general observers of spaceflight. We get to still cheer for any progress in getting a orbital rocket to the launch pad for the first time. And even if it gets off the launch pad a little bit, that would be a milestone, right? That would be some
GC
data
for
that would be
VC on ground.
That would be, a step moving forward. So, yeah, we're obviously hoping they have big plans. They're aiming for orbit. They're literally just going for it right away.
T-minus 14 minutes. RC, please contact the range and coordinate to begin recording RF tapes at T-minus 10 minutes.
Complete.
Okay. Some of the stuff will sound familiar. We had this, they're going through their checklist as they go down the sequence here. So we're going to be hearing a lot of call-outs about, recording, because it is valuable data to have video cameras pointed at, the rocket from all different angles if there is an anomaly. Some of those cameras are what helped SpaceX solve the Amos 6 issue that happened, was that 5 years ago yesterday, or was that 6 years ago? When was that? 2016, 5 years ago. September 1st, 2016, I believe. No, was it 2015? 2015, I think. I don't remember. But anyway, when that happened, they actually had to utilize a lot of ground tracking cameras to help solve what had actually happened as an anomaly. So that is a very valuable asset, the visual asset.
13 minutes. Ground side preparations, including TBC, TTAB, and spin start verifications have complete.
So everything's still looking good. That's exactly what we want to hear. We want to see them continue to move through this process. Yeah, very cool. All right. And this is cool. We have James Pettit out there literally hoping to see it from his backyard. That is cool. Living on the West Coast, living in California today would... And actually, I'm not
We'll now
asking
review
for a
actions
scrub.
on CD1. In the event of abort, we will perform the following steps. We will confirm there are no fires around the engine, utilizing FireX as called out by LD. If there are no fires, GC will turn off the world purge. We'll confirm vehicle health. The pre-valves are closed. Helium bubble is active. S1 fuel tank is maintaining between 30 and 36 psia, as read on A1S1 CFT. We will verify other vehicle tanks are vented. We'll confirm ground side health. The TTAB tank is vented, TVC tank is vented, spin system is vented, and cavity purges are active. We'll confirm with the range located disarm and power down the ESADs, and then we'll power off stage 1 and stage 2 FTS. We'll transition back to manual power. We'll re-engage the strongback via command changes on the hydraulics page. Error code 016 is expected to abort after T-minus 30 seconds. In the event of liftoff, operations team will move to the ground net and perform PRC MLP 1438, and RC will perform 1435 set operations on CD1. In the event of a hang fire, we will perform PRC MLP 8304.
Okay, so what I was talking about earlier for just a second is one good thing would be if they would have to scrub again later into the window today, we might see a beautiful twilight phenomenon where sunset out there is 7:30 and this is launching at 7. So if it were to launch around, say, 8 o'clock p.m., the rocket would be launching at nighttime on the ground. It'd be ground already, the sun would be down, it'd be dusk, and the rocket would be flying up, and it would actually get to the point where it's illuminated by the sun. And now, because it'd be West Coast, the sun would actually be back illuminating the exhaust plume, which is gorgeous. If you haven't ever seen a rocket launch that is being backlit, illuminated. It creates this beautiful thing called the Twilight phenomenon.
on GSWNet.
And it's just stunning. It's absolutely stunning. So if this would to get pushed back, we would at least have that bonus of the next opportunity in this window. Might be right during the Twilight phenomenon. So I wouldn't complain if that was the case. Again, remember, this is their first attempt ever. So we need to offer up some grace. And again, thanks to Firefly for allowing us to stream this and for this level of transparency. Even the comms, I mean, we're hearing comms. We have trench cam. They did a pointy end up, flaming end down check. Total win in my book. Like
LCRC countdown cool. 1. Recorders are on at TRS.
Copy RC.
I love just seeing people just cheering on Firefly. I think that's super cool. You know, again, as a card-carrying member of Team Space, I'm just excited about anyone working on exploring the cosmos and getting humans deeper into space and getting more and more people excited about spaceflight. This is a fun company that works really hard and is doing some really unique things. But they have a great company culture. I got to visit them in January. Walking around was awesome. You can just tell when people enjoy what they're working on. And the teams that I interacted with and everyone they were so excited about the things they're working on. I mean, it is just awesome. It's unbelievable that you can have a field out in Austin where people are just building rockets in some hangars. I think it's super cool. Really impressed though with how they've ramped up production already, and they're going for it. They're really just going for it. And then their headquarters in Austin is really cool. So yeah, I'm a big fan. This, like I said, this does mean a lot to me to be able to be the official stream provider for them. I don't know why they're trusting me to do this. If you're new here, hi, welcome. I'm Tim. I don't work for Firefly. So the fact that they're trusting me to just talk about stuff, pretty nuts. Pretty cool on their end. Sorry, I was trying to listen to that. This is a great question here, asking from Oscar if I would make a video about tap-off cycle rocket engine, because it isn't in the Raptor King of Rocket Engine video that I made, where we talk about engine cycles. That is an upcoming video where I will just do a video only about engine cycle types, because there are other ones that we didn't talk about in that video, and I think it would honestly make a lot of sense to just make a dedicated video about how you can make a rocket engine run and the different cycle types. We can talk about tap-off, we can talk about the bleed expander cycle and the expander cycle. There's a lot of different tricks up sleeves that we didn't even begin to touch on in that video. So it'd be really fun to do a comprehensive video for you guys, because the tap-off cycle they're using here is really unique. And like I said, no rocket that utilizes the tap-off cycle has ever made it to orbit. I don't even think there's been a rocket that's attempted to go to orbit with a tap-off cycle. It is a very unique solution, and it's so cool that they're utilizing it on their rocket. Again, it's actually a pretty, as far as liquid-fueled bipropellant engines, it is a really surprisingly simple solution. It's almost as simple like the electric pump fed and pressure fed.
S2 TVC wiggles.
Stage 2, they're double checking that the engine up there in stage 2 inside the inner stage is wiggling. They kind of wiggle it. We can't see that visually, so that is a sensor thing. They might have a camera up in the inner stage that would show them that wiggle to confirm, but yeah, but I'd say tap off, as far as the amount of moving parts and everything, is about as simple as it gets for bipropellant outside of like pressure fed and electric pump fed. It's a really unique solution, and like I said, it's not the most efficient thing in the world, but that efficiency doesn't really matter at the end of the day, right? You're really worried about how much does it cost me to make an engine, how much does it cost me to produce this engine, and to the research and development of this engine. Kind of that dollar per kilogram of thrust concept almost. And if you're producing an engine really cheap,
LCVC on CD1.
Go for LC on CD1.
We are looking good for clearing the LCC gate at T-minus 3 minutes.
Copy that. T-minus 6 minutes, Alpha switch to internal power. Strong record track operations will begin shortly. Arms are open.
Little spicy spicy debate there of shuttle versus Baran.
Strong back retract.
So
please
you can see
disposition
now.
LCC gate checks for the T-minus 2 minute checks. T-minus 2 minute checks. Any
Inward.
no-go at this time will be an automatic abort.
You can see there the strong back retracting. Again, that's a good sign. So that's right on. So the next thing we'll hear is they'll talk about the flight termination system being
T-minus 5
armed.
minutes. Strong back is secured in the launch position.
Again, I gotta say, for their first launch attempt, it just sounds like everything's, they have such a nice order to things, and things are just running so smoothly. It's really impressive to see this for a first time launch ever. I did see a really good question right now from Grant. I'm just gonna pull this up here real quick. And we'll try to get back to some of the other ones. What is it exhausting off the rocket? So again, it's literally what you're seeing coming off is literally just boil off of liquid oxygen. So there's a lot of liquid oxygen on this vehicle, and when it warms up, it expands, it heats up, and it'll shoot out the side of the rocket. They vent it because when you take a liquid oxygen and expand it into a gas, heats up and turns into a gas, it expands 1,000 times. So you can't have that inside the vehicle anymore, so you vent it out, and that's what you're seeing, and that's totally normal. Again, think of like opening a freezer on a hot day or something.
FTS confirm FTRs are active and range is transmitting check channel 4.
FTRs are active and range is transmitting check channel 4.
Note the Arm Enable 2 command must be received by the ESAD within 30 seconds of receiving the Arm Enable 1 command. FTS, send Arm Enable 1 command to all ESADs.
Arm Enable 1 command being sent in 3, 2, 1, mark.
FTS, send Arm Enable 2 command to all ESADs.
Arm Enable 2 command being sent to all ESADs in 3, 2, 1, mark.
FTS, confirm all ESADs are enabled.
All ESADs are enabled and armed.
All right, so that it means the flight termination system is officially active on the rocket. And again, if there were to be an anomaly with this vehicle,
T-minus 2 gate complete.
Copy, C. T-minus 3 minutes. Fuel bleed is starting.
all right. My heart rate is racing again.
Here we go,
Yeah.
guys.
So again, flight termination system armed. If this thing gets off the pad and starts to ascend, and if there is an anomaly where guidance doesn't work correctly or something, they have the option of aborting the rocket, which will terminate the rocket and make sure it doesn't fly towards Los Angeles or nearby Lompoc or Santa Barbara or something like that. That is a requirement for orbital launch vehicles, especially when you have this much payload and this much fuel on board. They have to make sure the public is safe. That is what the flight termination system is for. But yeah, they're going for it though. Again, guys, remember, this is their first ever launch attempt. So we'll be listening in here during these last 2 minutes for any kind of call out.
T-minus 2 minutes. CE has completed their final LCC. Checks for launch. This is the final commit for launch. CE.
Send it again.
Launch director.
Go.
LDA.
LDA, you go for launch.
Copy, LDA. VC, please verify Alpha transitions to autonomous mode at T-minus 30 seconds.
Okay.
Send it again. I love that. That was referring to the rocket. He's saying, send it. And he had already said that on the net
Wait,
earlier, so saying, send it again. They're ready. They are ready to launch this thing. I love that. That scared me. That was loud.
Okay, guys, 1 minute.
Here we go. Coming up on T-minus 1 minute.
60 seconds.
I'll be able to talk this time during the launch because my family's asleep.
Toxic press started.
Trench cams looking awfully condensed there.
To stop the count, operators please declare abort, abort, abort on CD1 and VC will abort the auto sequence. DC at T-minus 30 seconds. Verify alpha transitions to autonomous.
30 seconds.
O2 engine levels are at 2%.
If it launches this time,
20.
it's gonna be really beautiful because sunset in the background.
Just that little bit of gimbal there.
15.
Oh man. 10, 9,
There you
8,
go. Good luck,
7,
Firefly.
6,
9,
5,
8,
4,
7,
3,
6,
2,
5,
1,
4,
0.
3, 2, 1. 0-1-0-0 Zulu.
RC transition operation procedures to PRC MLP 1435.
That's
IP
so
to
cool.
PRC MLP 1457 report anomaly. Please confirm I have no fires on the pad. I have no visual. Please confirm no fires on the pad.
There are
Listen,
fires on the pad, but that's so cool.
I'm looking. I'm about to send them all. The
Looks like nominal.
pad sweep. Cameras are sweeping the pad.
Plus 32 seconds.
Stage 2 pressure's up.
Prop call.
Let's go.
Prop is nominal.
That's so cool.
Oh my god, they're doing it.
GNC.
I'm seeing a dip in VMAG.
There's no
Again,
there's no fires on the pad.
Avionics.
Okay, so fires are out.
Responding AVI.
That is so cool.
S1 pressure profile nominal. Avionics power nominal. Telemetry
First
is
ever
nominal.
attempt. This is their first ever attempt at going to space and going into orbit ever. And they're coming up right now on maximum aerodynamic pressure. That is the moment where the vehicle will experience
Plus 130.
the most amount of aerodynamic pressure. So this is when you're really testing your fuselage. Is it going to hold up? We are going through that right now. So the vehicle
Yeah,
is
hopefully
clearly
everything
holding
goes
up.
good.
That is a
'Cause this is
great
when
milestone. We might even hear
stuff
Max Q call out on the
Not yet
comms net.
supersonic.
happen.
Not yet supersonic. That's maybe not great. The vehicle, there's a chance it could be slightly underperforming, but again, we'll wait to hear official call-outs here.
It's
But
past,
this,
it should be
again,
past Mach
first
1,
launch
it's not
attempt
even
ever
supersonic
of this
yet.
vehicle. It's unbelievable. They got off on their first try on their first day of their first attempt ever. This is unbelievable. Again, if they get to stage separation, that's going to be a huge milestone.
Vehicle is supersonic.
Vehicle is supersonic.
Yes, okay.
Wow.
Oop.
That's a good.
Oh,
Anomaly.
oh no, it exploded.
There has been an anomaly.
Move the anomaly team
No.
to procedure MLP.
Dang it. Why'd it explode?
Shoot.
Come on. They even make it to stage separation.
Oh, man. Shoot.
It looked like it was going good.
Oh, that was impressive, though. That was impressive. I was actually speechless. I just really didn't think they would go for it on their first launch window opportunity ever. Right? Wow.
Dang.
Wow.
I didn't even expect it to explode.
Everyone,
If it was gonna
just
fail,
send Firefly your love and say thank
If it
you,
was gonna
Firefly,
fail,
for
I-
allowing us to stream that. I mean, they didn't have to do that. They did not have to do that at all. They absolutely just showed warts and everything. Mad props.
If it was gonna
Everyone,
fail, I thought it
just
would
here
just, like, fall short
in
orbit.
chat, just
but I was not
just
expecting
everyone
that to
say
explode.
congrats Firefly because they did a lot today.
I saw
They
some,
did a
like, light, and I
massive
thought- I was like,
amount
oh, that's just
of
the-
impressive
the,
milestones. I mean, even
trail
getting
happening,
off of the
trail.
pad with
And
your
then
first
just
orbital
exploding.
rocket is a huge, huge milestone. So,
Okay, yeah. Yeah, thank you guys for watching. That was something. That was a beautiful launch. Didn't really look like it was going fast enough. Vehicle pretty much was underperforming, but great launch. Great success, Astra. That was really good for our first launch. Yeah, good job, Astra. Hope you guys succeed on the next launch. And yeah, sorry, that was something that just exploded. That was crazy. Okay guys, yeah, thank you guys for watching.